Yeah, so, wow, great audience. It's amazing how many people have turned up here. So just a little bit about this, because you know, we're a relatively young company, so you might not know who we are. Yeah, I should stand away from that. So while we're a young company, the joke is that we're made up of people that either have grey hair or no hair, and I fit in that category, and my colleague Zohar at the back also fits into that category. But we're a young company that does Wi-Fi, cloud-managed Wi-Fi, that really focuses on AI analytics as the key differentiator. So, therefore, I'm here to talk about, you know, what's marketing and what's real when it comes to buzzwords like AI and analytics, particularly when it comes to Wi-Fi. Because if you haven't heard of AI and analytics in Wi-Fi a lot yet, over the next months and years, you definitely will. And everyone will be getting in on this. And I think it's because of some of the things you saw in the first session this morning, where there are some relatively simple things that could be very easily automated so that the more difficult things can be focused on by experts. And so I think there's a lot of benefits through using the power of AI and machine learning when it comes to Wi-Fi, in particular troubleshooting and understanding not only is the Wi-Fi network up, but the Wi-Fi network is good. So that's the big focus. Does anyone know who this is? Where are my nerds at? No? Okay. So this is Christy Dennison, and she's a machine learning engineer at, anyone know this logo? OpenAI. So one of Elon Musk's projects is OpenAI. Anyone recognize the logo on the left-hand side of the screen? Anyone? Dota. Who said Dota? Yes. That's the logo for Dota. If you don't know what Dota is, it's a video game where 5 players play 5 other players, and they basically have to destroy each other's base by also trying to destroy each other. Very recently, there was a tournament where the prize pool for the winning team in Dota was over $20 million. So, you know, did your parents say you're wasting your time playing video games when you were younger? Well, if you're the best of the best, they are multi-millionaires playing this game. All right, so why does that have relevance to my talk? Well, OpenAI, of course. So, OpenAI wanted to do something beyond what had already been done with machine learning and AI. So is everyone familiar with you know, Go, the game, and how the neural network trained AI was able to beat the world's best Go player? Well, Dota is a little bit more complicated than that. Whereas things like chess and Go have very strict rules, and most importantly, all of the information about the game is available to both players, right? You can see what each other's doing. In Dota, there's a lot of things that are hidden, right? You have a fog, so you can't see what the other team's doing. So it's much more complicated than, you know, those board games. And so what OpenAI did was use reinforcement learning, machine learning. They basically fed, I think it was 180 years worth of Dota games to train this AI to see if it could beat the best players in the world. So last year, at that big tournament, they had very constrained rules, 1 versus 1, and it actually beat the professional players. So the AI was better than the pros. So this year what they did was, let's play a full game. There's still a few rule constraints, 5-on-5, and the pro players actually won. And so after the event, they kind of went through some analysis of why did this happen? Why wasn't that AI good enough? And what they actually found was that the AI plays very conservatively. So it goes for the high probability of winning, which is playing very conservatively. But humans took the risks, and the risks paid off. And that's why they were able to beat the machine. So this is an example of using, in this case, neural networks have reinforcement learning to constantly train the AI. And the thing to note about this is that it uses a lot of resources. Like, they threw an unbelievable amount of compute resources just to train this, and then a lot of compute resources just to run each of the individual AI bots. And so what you'll probably see is when it comes to things like AI and analytics that are extremely compute intensive, you'll likely be doing this type of stuff in the cloud because you need that scale. You know, you can see here they use 500 CPUs just to push the data, and they had multiple layers of that just to produce the outcome and train that bot over time. So it actually started out by not even knowing what the game was. Didn't even know how to move the character, and in the end, it came close to beating the best players in the world. So AI is really, really advancing as you know the years progress. Now, what often happens when you start talking AI is it's been so diluted by marketing that it's really important to understand the definitions of what we're talking about. So, you know, realistically, at a very simple level, AI is just something that can display human behaviors, right? Now, what you define that as being human behaviors is up to you. But at a fundamental level, that's all it is. And you're probably all familiar with the Turing test, which you know, the big test is, can you tell from the information that you've been receiving, is it artificial or human, right? And so artificial intelligence is actually quite broad. Now, inside artificial intelligence, that's when you start to get a little bit deeper. Whether it's machine learning, which is basically using data to change the way that the machine operates, right? So using data to change the outcome so it can learn over time. And then you have inside that deep learning. Now, the general public, when they think AI, this is probably what they think, deep learning. But it's much broader than that. So deep learning is using things like the neural networks, either CNN or RNN. So CNN is used a lot in like image processing, and RNN is used a lot in voice. So Alexa, Siri, etc. uses those. But this is, you know, having neural networks to understand images or process language, right? That's deep learning. What you also find then is there's a lot of data science involved, and this kind of overlaps into all of these areas. And so data science is, you know, using the data, using algorithms to have some type of outcome of information from that data. And so I think what you'll see in the Wi-Fi industry, or you're already starting to see it, but you'll see more and more, is that these types of technologies, and it might be some that is very broad, and there might be some that are very specific, will help you know, our customers, all of our customers, in making sure that they can operate the best Wi-Fi network that they possibly can. And we'll get into some of the ways that this can help. So to kind of, again, set some, you know, reasonable expectations of these things, and to give you an idea of some examples. So if you look at artificial intelligence, a good example of that is Alexa or Siri or Google Assistant. You know, these are virtual assistants that use some degree actually of the deep learning because they're doing some natural language processing. But you know, that's kind of your artificial intelligence. Machine learning, a good example of that is the Nest thermostat. Anyone have one of those? Yeah, a few. So it knows when you're at home and when you're not at home, and it can change its behavior and the way it operates based on that data. So that's machine learning, right? And then if you look at deep learning, probably not there yet, right? But when Tesla has, you know, full autopilot and full self-driving capabilities, that's where it's using its neural network to take input from a lot of sensors and then make decisions. And this kind of technology is kind of where OpenAI is going. So the reason why they focus on Dota is because there's lots of variables and lots of unpredictable things that people do in a game, right? When you're talking about self-driving cars, there's also predictable things, like the lanes, the speed limit, traffic lights, but there's other drivers, and that's unpredictable. So you kind of see how development in one area really leads into improvements in another area. And, you know, use this technology in Wi-Fi as well. And in data science, probably the best example, I'm a baseballer. I played baseball for 25 years. Anyone seen the movie Moneyball? Yeah? So the Oakland Athletics, I think it was 2002, they used data science to not pick the biggest names, but pick the players with the best, on-base percentage, for example. And so they used data science to build a team of nobodies that could compete at the highest level for a good price. And that's a good example of using data science. So hopefully that sets the scene and gives you a foundation of what are we actually talking about when we talk about AI, machine learning, deep learning, and data science while we get into Wi-Fi. But at the end of the day, if you look through all of these and then apply it to Wi-Fi, at the end of the day, it's all about answering questions that are on par with a domain expert. Now, that might be the North Star, that might be the goal. Notice how it says, it doesn't say answer all questions. Answer questions on par with a domain expert. So I think if you look at AI and analytics in that frame, that's a really good way to look at it. Answer questions that are on par with a domain expert. So we have that understanding of what AI, machine learning, deep learning, data science is. But how can we use these in Wi-Fi? So I'm going to spend the rest of the presentation looking at areas where this can be applied. Areas such as location tracking, radio resource management. There's already a lot of machine learning and automation in radio resource management, but it can get better. So how can AI and analytics help that? Probably the biggest one is troubleshooting, because put your hands up if you spend more than 50% of your time troubleshooting existing networks, when you could be out there deploying new networks. Or how much time do you spend just finding out what the actual problem is instead of actually fixing the problem, right? So AI and machine learning can really help in doing this type of troubleshooting. Also baselining. So particularly when you start to think about troubleshooting, one of the big questions is there even a problem? How do you know there's a problem? Well, today you do it based on alerting and alarming. But how do you know that there's a problem because it's not being used much or because it's performing bad? So baselining is an area where particularly machine learning can help a lot. And then even as a much better command line interface, or maybe as a better interface. So imagine having that Amazon Alexa or Siri experience where you can ask the network what's wrong with itself, instead of typing it in or navigating through a UI. So that's another example. And then probably the nirvana is something like auto configuration. And again, with radio resource management, you kind of getting some of that, where it's a closed loop feedback, where we see something's wrong and we can automatically change it to fix it. But that obviously requires a lot of trust, right? You need to know that it's working well. The aviation industry went through this, and it's still going through this. You have a lot of automation in things like autopilots, but would you trust going in a plane if there was no human piloting it? Who knows, right? So trust is an important thing when it comes to auto configuration. So what are we actually talking about here in terms of the actual underlying technology and algorithms? What you find here on the y-axis is the further north you go, these are the kind of technologies that you're more likely to find in AI. And across the bottom here is the algorithm complexity. So the types of stuff I showed with Dota using neural networks, that's obviously up and to the right? That's real deep learning AI, and as you saw from what they needed to train those bots, highly compute intensive, right? But there's all these different ways that you can look at using AI in Wi-Fi. You can look at it for time series anomaly detection. So understanding across a time period, when have I had an issue, and when is it anomalous? It could be looking at things like unsupervised machine learning. So whereas Dota fed a whole heap of information to the OpenAI bots, to train it. You can also do machine learning with no training and just have it learn as data comes in, right? And then the Dodo version, which was using this reinforcement learning, which can be used in RM, which I'll talk about. So let's look at the first one, location. So a little bit of a summary of how location works in Wi-Fi and in RF in general. If you're new to this area, there's kind of like two ways to do this. You can either have the access points send out signals, and the client listens to it and gets its location from that. They're typically used in use cases where you want to provide the location to the end user, so engage them, right? Provide location services to them. So like Bluetooth uses this technology, where the BLE beacons in the access points, or if they're stemplane beacons, beacon out at a constant rate, and the phone listens to those beacons, and based on the signal strength, so signal strength is used for ranging, it can determine its position in space. This is actually very similar to how GPS works. It's obviously a lot more complicated, but at a fundamental level, the satellites send out a signal, and the GPS receiver listens to the signal to work out its point in space. The other way is this visibility way, and this is really how Wi-Fi location tracking works. So the device sends out something, in this case Wi-Fi signals, and the network listens to those and then trilaterates its position based on signal strength. But that's the important thing. In both cases, signal strength is what's being used for ranging. Now, we might see in the future things like time of flight or time difference of arrival, but that requires accurate clocks on these devices and time synchronization and all that. Where we are today in the industry, it uses RSSI. And so, there's this curve that you're probably all familiar with. That the further away you get from an access point, the signal strength drops off. It drops off a lot very quickly and then kind of peters out. And so you build up these models, these path loss models, to translate that signal strength into distance. That's how location tracking is done. But what if they're different devices, right? What if it's an iOS phone here, it's an Android phone there, it's a medical device that's maybe 10 or 15 years old over here, that all need to be tracked by location. Anyone know how we solve that problem today, all the time? You do calibration. Anyone done a calibration of a location deployment? Yeah. What does it involve? A lot of walking. Right, exactly. So you go to each point, you take a reading, and it's mainly used for the environment, right? So understanding how reflections, refractions, obstructions impact that curve to determine the distance. But we can use machine learning to solve the device problem, because my iPhone 10 here is going to have different RF front ends, so antenna, etc. Properties to my laptop, or this laptop, it's not mine, or everyone's phone in the environment. And so the path loss formula is going to be slightly different for everyone. So we can actually use machine learning to handle that. So if the client device is constantly sending the signal strength information that it's receiving back to the network can build a picture of how each client is performing. So, a lot of technical detail here, but what these numbers are basically doing is adjusting that curve. So that path loss curve, it's adjusting it for whether it's an iPhone 6s, an iPhone 10, an iPhone 7, an HTC device. So this is using unsupervised machine learning, because we're not teaching it anything. Because in this example, teaching it something won't really be applicable. Because what if next month a new phone comes out, or next year a new phone comes out, and that's going to appear on your network before the vendor is going to be able to teach the system about that. Using that information to then adjust that particular curve. And of course, if you have some type of cloud-based connection, it means that the data that customer A gets on an iPhone 10 could be shared with the customer B, so that when it appears on their network, they can adjust that location algorithm for that particular device. So that's a good way of using machine learning to solve an actual problem. It means that you could deploy a relatively accurate location-grade deployment without having to do that calibration that is quite time-consuming. The second one I want to talk about is RRM. And I mentioned that we're, as an industry, a lot of these concepts, particularly around data science, is already being used in RRM, where you look at the neighbor signal strength level, you look at the interference or the channel utilization, and come up with the channel plan and power plan to apply. But what are the problems? If you look at critical environments, I mean, how many have you deployed in hospitals? Right? When do you run your, if you run RRM in those environments, when do you run the RRM calculation? Middle of the night, right? And look, a hospital might be a little bit different because it's kind of busy all the time, but there'll be environments that are very quiet at night, very busy during the day. And pretty much all implementations of radio resource management are a snapshot in time. So it's, have a look at the environment now. Okay, I see channel utilization here. Everything's quiet maybe, don't change anything. But come 7 AM, 9 AM in the morning, when everyone comes in, that's really the data that you want to use. So with radio resource management, you can use machine learning and time series anomaly detection, right, to understand not only what is it like right now, but how's it been for maybe the last 24 hours or maybe the last 7 days, and build up a picture that is the best channel and power plan for when it actually needs it, which is when it's busy, right? Not when it's quiet. So I think this type of AI-powered RRM is really, really important. The other thing that you can do, particularly when you're looking at scale, so whether it's cloud connected or whether it's feeding data back to cloud, you can then kind of do some reinforcement learning. So look at all of the channel plans across every deployment in the world, feed it into your RRM algorithm and see, does it actually improve things overall across the whole globe, right? So again, using this data and data science to feed into maybe a neural network-based radio resource management to do that. Troubleshooting, and I mentioned this as kind of a big one, because, and I think you'll all have experienced this, but let's look at the current state of problem detection in the market. Usually it's alarm-based, and this is quite common. That you break down your different device types or parts of the network, and you end up, if you look at the network, currently 1,356 alarms on that network. Now, I don't know about you, but when I see 1,365 alarms on the network, am I going to care if there's one more? Right? How do I know if it's a really bad thing that's happening or if it's just an alert? And what generally happens is that these alerts get sent to an email inbox, and automated notifications, 1,399. This is a real screenshot from a real engineer, and they haven't checked those alarms because it's the boy who cried wolf. If you keep sending data and it's not valuable data, it'll just get ignored. So that's what's happened. And you're probably very familiar with things like this, where you have a lot of alarms, and then even the best one is there's so many alarms that just has a plus at the end. Now, you probably know where these screenshots are from. I'm not having a crack because my employees are innocent either. This is an industry-wide thing where alerting and alarming can just overwhelm a network administrator. In this example, DHCP is not responding to requests again and again and again and again and again. Right? If I keep seeing this, eventually I'm going to ignore it, and therefore the alerts are useless anyway. So this is a big problem in the Wi-Fi industry altogether. So, at the end of the day, what I think, and let me know if you've got different things that you want to know, but I think, you want to see what's the health of the network. And again, it's not, is it up? It's, is it good, right? You want to know the W's, the who, if there's a problem, who is it affecting? where is it being impacted, what's being affected, and then in particular, why, and also when did that problem happen. So that's really important to get to. And I want to be alerted when things are actually bad. Don't just send me, as you saw, an alert that the DHCP server's not responding. You know, show me when there's something that's actually really, really bad that's happening. Although that is probably pretty bad if a DHCP server's not responding in Wi-Fi. So, how can we use AI and machine learning for this? So, for health, one of the most important things in all of this, and this goes back to the Dota example, is the data that you're getting is really important. So, you know, rubbish in, rubbish out. If you look at Dota, the OpenAI, one of the big advantages that the AI has is it has a very open API that can consume all of the game information. So whereas a human has to look in parts of the screen and click on different things to see the state of the playfield, the AI gets it instantly through the API, right? Again, when you're talking about health and visibility of the Wi-Fi network, you could sit there clicking through an AI to gather data, or through the UI to gather data, but the AI through APIs has it instantly. So that's a big advantage. And so once you have that data, and it's the right data, you can then abstract it into higher level metrics. And so, you know, in Wi-Fi, what do we really care about? We care about, can my clients connect? Right, that's a really important one. Probably number 2 is, how long does it take them to connect? That's a big one. And then once they're connected, what's their experience like? And their experience is usually around what's their throughput they can obtain. And that actually needs a bit of machine learning. Because how is throughput typically measured in Wi-Fi? Speed test, bytes in, bytes out. But that assumes someone's running the speed test at that time. Just because the network isn't being utilized doesn't mean that it's good. And just because the network is high utilization doesn't mean it's bad, because it could be being used. So use machine learning to understand what's the channel utilization combined with the RX-TX rate, combined with the client capability, combined with the access point capability to come up with a model for throughput and what the expected throughput in that environment would be. So that's real machine learning, to come up with something like throughput. Once they're connected and they're passing traffic for throughput, you're concerned about roaming. How long does it take a client to roam from one access point to another? And again, most importantly, how has that changed over time? So that's really important. And then, of course, some people might be, looking at some of these older metrics, things like AP uptime and coverage. They're pretty much well understood in the industry. Coverage is easy. How's my access point hearing the other access points? One thing that's a little bit different nowadays is you can actually tie location tracking that we talked about before with coverage. So if you know where your clients are because you're locating them with Wi-Fi or with BLE, and you know the signal strength you're receiving from them, you could then do a heat map based on location. And that's something that we do. So these kind of metrics allow you to have that high level visibility of the health of the network. And then set things like service levels so that you can understand if they're being met. So that's kind of the health. If we then go into the W's, this is where it starts to get really interesting. So this is where you go that layer deeper to understand what's actually going on. Why is the health of my network deteriorating? Or why is it good, etc. So if we look at the who, the where, and the when, some of the things that you can do, concepts like mutual information. Anyone heard of this before? It's kind of like hybrid data science, machine learning technology, where you're looking at basically correlation, right? But it's using maths to understand the correlation between things. So in this example on the left here, I'm looking at a problem with successful connections. So I'm looking at why aren't devices connecting successfully. And so the mutual information allows us to narrow down the problem to maybe a particular device type, or a particular SSID, or a particular frequency space. in order to narrow down that problem. So we actually had a customer that had a network outage at one of their sites. It's a brand that everyone would know, and they use Wi-Fi, and it's critical to their business. And they thought they had a network outage. They came in here and saw that it was only affecting one client. So straight away, you save some maybe blood pressure from understanding what is actually being impacted, what is not. And if it shows a particular device type, you can then narrow down what the problem was. In their instance, they actually that night pushed a certificate that was expired. And so that particular device type couldn't connect to the network. And really, you don't have to provide, and you know this from troubleshooting yourselves, you don't necessarily have to provide the actual root cause to get an improvement. Sometimes just showing this amount of data is enough to get you to the source of the problem. If you look at over here, this is really looking more in depth about the who. So it's looking at the actual affected items. In here you can use technology like Bayesian inference or Bayesian machine learning, where this is basically where you've got a set of data and you've got new data always coming in. And you want to update what you perceive to be the answer. So as new data comes in, and in a Wi-Fi network, as people are connecting or roaming around, new data is going to be constantly streaming in. So understanding things like the impact and the failure rate, you use Bayesian inference in order to update that particular score. So not only do you know who or what's being affected, but you also know how much are they individually being affected as well. When it comes to what, you can use AI to simplify the problem. So you can have it in natural language, say, the problem is with the DHCP server. It's only affecting a small number of clients, or it's client specific, or it's widespread. So again, as your network administrators can then get and resolve the problem a lot quicker because it's pointing in the right direction. So AI can help there. And then when it comes to the why, this is kind of more of the data science, where you can capture states that clients get into and have anomaly detection, so that when something bad is detected, automatically have a pack capture of that event, so that you don't have to. And a lot of people would be familiar with this. You have a problem, and you need to come out and fix it. And particularly if it's a roaming problem, how many times are you going to be up and down trying to capture that particular event? That same customer that had that other problem actually had a problem with some devices roaming, and they'd had it for a long time, and then they deployed Mist, and this triggered an 11R roaming problem and got a packet capture of the event without them having to do anything. And they could then send that to the vendor, and the vendor was actually able to fix their driver. So it was actually a client problem, and they saw it here. So this kind of looking at the why of the analytics. Now, when it comes to the third one that I think for troubleshooting, it's how do you know when the problem is actually bad? And in my opinion, this is really about baselining. So what is baselining? Well, you need to understand what's normal. And not only do you need to understand what's normal, but you need to understand what's normal at different parts of the day, right? Because out of hours, normal might be a low number of clients, whereas in the middle of the day, a high number of clients. And so obviously, the number of failures might be higher in the day, but the percentage of failures might be higher at night time, right? So baselining needs to be adaptive to the actual environment and the time in order to know what's normal. So this graph on the right here is actually a graph from our radio resource management, looking at every single access point in the world that is deployed, and then understanding the neighbor relationships. So the signal strengths of the neighbor relationships compared to utilization. So this is our reinforcement learning. So we can feed this data into the algorithm to see on a global scale, is it doing its job? So that's again using baselining. So to kind of give you a visual of what I was explaining before. So in these graphs, so there are two different graphs. One is zoomed out and one is zoomed in. but you can see in the blue the total attempts to connect, and in this kind of purpley colour or maroon is the failed attempts. And so what you see as time increases, the actual failure percentage is rising. But the reason it's rising is because the number of clients is decreasing. And so if you use static baselining, this means that every night your baseline or your alert's going to be triggered. So it doesn't have any smarts to know that I'm not just concerned about the failure rate, I'm concerned about the time of day and other factors as well. So dynamic baselining is really important. So we kind of need to get smarter. So you need to understand the environment and only highlight anomalies when there's an actual problem. And again, this uses a lot of machine learning in order to achieve this. And that means you can send in emails about an anomaly instead of being spammed by alerts from a network management system that's basically taking SNMP traps in and sending out emails northbound. And then also use the AI, as we saw again, to take that action. So kind of had this full flow in order to get smarter. Now the last one I wanted to talk about was using AI as a much better or smarter CLI, or maybe just a better interface to the network. Now, if we look at CLI versus UI, Wi-Fi was one of the first networking technologies to really take that big leap towards UI with control-based architectures. But CLI is still pretty good at getting exactly what you want, right? You want to list the clients, you know what command to run, if you know the command. So the bad thing about CLI is you need to know the exact syntax, and that's obviously not very good. And it's not presented in a way that's nice. You don't get those graphs. You get a lot of statistics that you then need to piece together. Now UIs are well presented. So you saw one of those screenshots of the graphs and etc. Presentation is really good for a human. And the navigation is easier than the CLI. You don't need to know syntax. You can click through menus to get to what you want. But with a lot of data, particularly over time as a product grows, things get hidden in UIs, and you need to know where you want to look. Now you could have a good search engine, but how many good search engines are out there, realistically? So things get hidden. So what you can do is use natural language to kind of become a CLI for a UI. So you get kind of the benefits of both worlds. So if you want to troubleshoot, and this is kind of maybe a more existential question, what's wrong with Matt? Probably a lot of things. But you can use natural language, the types of stuff that you see with Alexa and with Siri, using natural language processing, using those neural networks in order to understand. When I say what's wrong with Matt, I really mean troubleshoot Matt's iPhone, and then show you the data and the reasons or what's happening. So a coverage area that's affecting a small number of clients in the 5 GHz band. So there you go. It could be used for things like, how many iPhones. So instead of, going to a command line and, having to show all the clients and then export that to a CSV file and then filter on any iPhones, you can ask the network that simple question. Or it could be, what type of clients are there, and list the different types of clients. It could be something like, show me which are the busiest access points, so you know where you need to add capacity. Again, it's about having a simple question, but getting well-presented data as the output. Even things like what's wrong with a particular access point, and then seeing things like the channel utilization, which channel they're on, and when they change channel. So, this type of data can be presented in a UI, but by asking a simple question. So you kind of see with AI and analytics, there's these two approaches. You can have these high-level views where you look at the health of the network. But if you want a specific question answered, that's when AI comes in, you ask the question, it gives you the answer. So these are quite interesting. Now the other thing you see that's probably, I saw that there was another vendor that was talking about integration with Amazon Alexa, right? Maybe you can use AI for configuration. Now again, if you're thinking about security, you're thinking in the right space, right? But an example could be using Siri to say, hey Siri, turn on social media in the classroom. So what if you're a teacher and you're in a classroom environment and the school blocks access to social media so that the kids focus on the class. But you're doing a lesson on the dangers of social media, so you need to allow access, right? Instead of the teacher having to call up IT to make a change, what if the teacher could use a virtual assistant in order to make that change for him or herself? So hey Siri, turn on social media in classroom 105. So, you know, with Siri it uses HomeKit. So the phone uses natural language processing. It gets sent to Apple Cloud, HomeKit. I said Siri, and so my phone is. Now, anyone know a piece of software called Homebridge? Yeah, a few. So Homebridge is a way to bring non-Apple ecosystem devices into the Apple HomeKit ecosystem. So I use this at home for like opening my garage door, for turning on my ceiling fans, for opening the door lock. So that you can run it on a Raspberry Pi. Have a look for Homebridge. Well, Homebridge has a lot of these modules, and one module is something called Command Switch 2, where any switch in the Apple ecosystem can be just a Linux command line. Now, if it can be a Linux command line, what can you do? You can call a Python script. And that Python script could talk to an API that then pushes a policy to an access point to block social media or allow social media on a particular access point. That is, you know, because you say classroom 105, it only applies to the access point in classroom 105. So yeah, like I said at the beginning, if you think about security around this and people being able to, you know, that obviously needs to be addressed. But this is the kind of world we're living in because of virtual assistants and open APIs. This kind of stuff can be done. And by the way, this is real because I built it. I can say, hey Siri, turn off social media in the classroom.
Okay.
Done. Now you have to trust me that it actually happened. But if you go to Bitbucket and search for Matt Fowler, all the Python code's there that steps you through how to get this kind of thing set up. So it does actually work, trust me. So you know, that's a great example of how AI can be used for configuration. So that kind of brings me to the end of what we're talking about in terms of AI and analytics and Wi-Fi. But what I started with when I started getting into the Wi-Fi stuff, I think is important to end on. You know, beyond any of the marketing hype and the salesmanship, I think the important thing to remember is that the goal of AI and analytics is just to answer questions that are on par with a domain expert. So I think that's the one thing you take away from this this session, that'll be a really good thing. So yeah, thank you for listening.